we are now on the third part, second half of our webinar for tonight. So this time we're going to talk about the core concepts of SDR, software defined radio, and SDN, our software defined network in modern infrastructures. Okay, so this is where the programming and the network and communications somewhat like converge. Okay, they are now simultaneously playing an important role with each other. So let's define first SDR or software defined radio. Okay, so radio communication system in which a single radio device can change frequencies, modulation schemes, and communication standards just by updating the software. Okay, imagine your radio as in AM or FM. So before the before the advent of smartphones, if you can still remember, if you were there, if you were existing already, if we want to change frequencies or tune to another station, meaning we change frequencies, we have to dial something. You have to turn the knob uh, at a certain angle to change the frequencies. Okay, and then until you get to um, tune into another station. Okay. Um, Also, aside from the frequencies, modulation schemes like uh, from AM to FM, from analog modulation to digital modulation. Okay, so we can now change that also with the help of SDR. So aside from the frequency, by just updating the SDR interface to change the frequency, we can also change the modulation schemes, and not just that, the other communication standards, including the coding techniques. Okay, all using the software only. So no hardware that must be reconfigured or replaced. Okay, so you can do all these things, all these changes using your computer only, or even your phone or tablet. And when we say SDR, we basically refer to the reconfigurable and programmable radio processing via software interface using digital signal processors, field programmable graphic arrays, or microprocessors. Okay, so basically, just imagine it's like a very small device like this, so somewhat like a dongle, wherein we adjust, we configure their operations or their parameters using the interface only, like this. So we have an interface that is displayed on that is running and displayed on our laptop or a desktop computer or even our smart devices. And we can make some adjustments there, adjust the frequency, adjust the modulation schemes, the coding techniques, and other communication standards. So that we can achieve whatever the result that we have, such as tune into a certain um, station. Okay, but if you are saying, oh, it's just like an AM or FM radio on a phone or on a computer, no, it's more than that. With the help of SDR, we can also see other wireless signals being transmitted within our area. Okay, so it depends on your antenna. Um, you can okay. Let's zoom in and take a look at the components of our SDR dongle. So this is an example of an SDR dongle. So it's not that complicated. It's like a flash drive. Um, of course, we connect it to our laptop or desktop computer via USB. And one of the main components here is the RTL2832U. So this is the let's say SoC or system on a chip that serves as the brain of this dongle. Okay, so RTL 2832U, so the SOC. And then another crucial component is the clock crystal tuned at 28.8 megahertz. So it has something to do with the timing, okay? Not the time, but timing. So how do we manage our digital pulses, especially? Um, okay, we also have the R820T. I think it has something to do with conversion. And then the connector for our antenna. We have the IR sensor for our remote. So we can have our, aside from our laptop or computer, you can have a remote device to uh, imagine you're changing these things. You are controlling this interface using a remote control also, so that you don't have to go near your laptop and do some configurations. You can make use of a remote control. Okay. Also, of course it has an indicator of whether it is turned on or off. Right. So as simple as this, we can do a lot already. Okay. So imagine you have the power to receive everything that is being transmitted wirelessly within your area, okay, using just a single device. It's not just about AM or FM radio, but also you can use this to receive signals, detect and receive signals, detect and decode signals from digital TV, from um, amateur radio, ham radios, or any other communication, even wireless and Bluetooth and cellular signals can be detected. It depends on the configuration of your SDR interface. Okay, so just imagine everything wireless can be seen here. You can see all this. This is the spectrum of what's currently um, being detected. So you can make adjustments so you can see more. Okay, so you can see the spectrum and then the spectrogram. Okay, so more than that, let's have another example here so you can understand more how it works. Okay, we have two examples here, two different interfaces. So basically, you just purchase a certain SDR dongle. Better if you can have an antenna coupled to it, and then just download and install an SDR software like the one, I think this is SDR Sharp. Okay, so just like this, so this is how it works. The SDR is tuned at a certain frequency. I think it is in terms of megahertz, right? So if we want to enhance the signal, for example, the signal that we are receiving is quite noisy or weak, then we can make use of some enhancements here on this panel. Okay, we can change the modulation technique, the coding technique, of course, the frequency of tuning by just dragging this green part. You can change, we can tune to uh, well, any portion of the spectrum that we want. Okay, and here using the waterfall display or the spectrogram, waterfall type of spectrogram, you can see here that this portion actually has intelligence or a message. It contains some data, while the rest are somewhat like just noise or some irrelevant signals. Okay, so with that, it's easier to tune into a certain wireless communication system. Okay, another example of an SDR software here has this kind of display. Okay, so that's it. You just need to choose a dongle and then the corresponding SDR software for it. Okay, so especially if we add the concept of cognitive radio. So this is a technology that adds an intelligent layer of software so that SDRs like this can dynamically adapt their transmission or reception parameters based on the environment and spectrum conditions, improving spectral efficiency and reliability. By the way, I forgot to mention that SDRs are not just for receiving. If you want to build your own wireless transmitter, you can also make use of SDR. So you can have a dangle like the one I showed earlier, and then have a certain SDR software, and then you can now transmit your own signals wirelessly. Okay, and whether you transmit or receive with the help of cognitive radio, somewhat like the AI component, you can now don't need to manually configure these things. So the ones that I mentioned earlier regarding how AI can help in communications and even in networks, they are now achievable with the help of cognitive radio. Okay, so now let's talk about the other one, the SDN or software defined network. So this is an approach to network management that uses software-based controllers to manage and control network traffic. So we are now focused on the network controllers actually. And the fundamental principle of SDN is the separation of the network's two main functions or planes. We have the control plane and the data plane. So something like this. Okay. We have traditionally before SDNs, we have the in every switch we have the control plane and the data plane. So if you want to manage your network, you have to manage both. Okay. So but if you have an SDN, you can now uh, you can now manage everything within just a single interface. All the control planes can now be gathered and collectively managed in just one interface, leaving us with the data plane still independent. Okay, so that's a brief overview of SDN. The other one is here. So SDN works like this. So we have the control plane and then data plane and then the application plane. So this is the SDN that we are going to focus on in our next slide. So we have the external applications. We normally create our own application or just use an existing one from GitHub or from some other reliable website. Okay, so these planes, as you can see, are connected via an API or application programming interface. So no need to worry about the different brands or protocols or programming languages they are built upon. They planes can be connected together regardless with the help of APIs. And as you can see, the control plane is the one that we actually focus on when using our application plane. So that the API in between them, these two planes, is called the northbound interface, while the other one is the southbound interface. So if we are concerned on the data, um, um, the the API between the control plane and data plane is, or the default and most common API that we use is the open flow. So the open flow is in the southbound interface. Okay, so application plane, we have the external applications. Control plane, we have the network services under the SDN controller. And then the data plane, that's where the network devices, or the data plane is within the network devices themselves. Okay, so we have an example here. This one is more exclusive to Cisco devices, the proprietary SDN of software device of Cisco devices. right? So here we are just basically now managing the network controller with the help of this interface. Okay, so what would you like to? So with the help of AI, we can simply type in what we want, and then it will help us navigate through the interface. Okay, so that's how advanced Cisco is right now in the field of SDN. So on the other hand, we have this simpler or less proprietary example of SDN. So here it shows operations visibility. Um, we get to see the resources, hardware status, the SLA status, and the applications up status. Okay, so as simple as this, we can check and monitor our network from time to time. Okay, including the storage um, involved. Okay? So in an SDN environment, a centralized SDN controller acts as the brain of the network. It has a global view of the network topology, programs routing decisions dynamically, and can prioritize block, reroute, or shape traffic instantly. Okay, so these are the features that we already mentioned earlier. So with the help of SDN, we can actually have an interface. So basically the interface for that is the SDN. Okay. And when combined, we can do a lot with the, of course, the new features and the emerging trends in telecommunications. SDR and SDN are a big help actually. So a little bit of comparison. Remember that SDR manages wireless signals while SDN manages network forwarding and routing. Okay. While also SDR is in charge of dynamic frequencies modulation and spectrum use, SDR takes care of the dynamic bandwidth allocation, the quality of service, and traffic policies. Okay. And while SDR replaces radio frequency hardware with software, so that's why it's called software defined because we are changing the software and no longer touch much on the hardware. The hardware is more like permanent already, and the software is the one that's being operated, okay, being managed from time to time. So while SDN, uh, SDN replaces manual network configuration with control software. So they are the same actually in terms of this. The only difference is what they have replaced. Okay, so SDR changed hardware to software, while SDN changed software to software. So network configuration is before SDN is already using software, but with the help of SDN, we are now more focused on the control aspect. Okay, we can now control the different devices using a single interface. And when combined, a radio network can modify frequency and bandwidth while the SDN core reroutes and prioritizes traffic. So this is somewhat um, essential in what we call RAN or radio access networks or RAN. Okay, so telecoms can create network slices with the help of SDN. Virtual networks tailored for IoT, industrial manufacturing, gaming, or emergency services. So also, military and emergency systems can quickly deploy communications in disaster zones with the help of SDRs, even without fixed infrastructure. So instantly you can have your new infrastructure in a selected part, like in wherever the disaster has taken place. So if there's no existing infrastructure, you can have one with the help of SDR plus with the help of SDN. Okay, so these two actually um, um, hold or play a very crucial role in the advancements that we have right now in our modern telecoms infrastructures and operations. Okay, so that's it for this part. I hope you have learned something. I really encourage you to look to watch some videos about SDR and SDN. These, especially if you are an ECE, a practitioner or a student, um, you have to embrace these trends, these modern and emerging technologies, because we have no other way but to keep moving forward. Okay, so we have some videos actually here that you can watch as you complete this quiz and evaluation